All right, so 8.2.2, how do I know about the roots? Let's just continue on with what we've done before. So the degree is based on, in a sense, how many lines, right? 1, 2, and it's also based on the roots, but if there's a repeat, you might not see that. So it's degree 2, which means it's quadratic. Let me zoom that in a little bit. And then the real roots, it's really crossing the x-axis. It's really crossing the x-axis 2 times. So if it's 2 real roots and the degree is 2, there's no complex roots. Now some of you go, what's complex roots? It just means imaginary. It's complex. It's imaginary. The name of this would be a quadratic, which is x squared. All right, pen dying already. X squared. All right, let's go to the next one. The degree, 1, 2, 3. Real roots, 1, 2, 3. Complex roots, there aren't any. If there's 3 of them, it's a cubic. Okay. I also want to point out this is a positive x squared, and this is a negative x cubed. Know those things, okay? Degree, 1, 2. Real roots, it's not crossing the x-axis at all. That means that both of them are imaginary. And the name is quadratic, and it's a positive x squared because it's going up. Okay, degree, 1, 2, 3. Real roots, it's really crossing 1 time. The complex roots, that means there's got to be 2, and it's a cubic, negative x squared. Oh, just kidding, negative x cubed. I want to tell you that this problem reminds me of if you had something like x cubed minus 27, and if you factored it, it would be x times x times x, 3 times 3 times 3. So if you went like this, x minus 3, square the first guy, square the last guy, take these two, put them together. If this is minus, plus, plus. If you set this equal to 0, that would be a real. And if you set this equal to 0, you can't factor it, so you'd quadratic formula or complete the square. I'd probably quadratic formula this because this is odd. Completing a square with an odd number is annoying, and those would be your complex roots. Versus this would be, okay, I factored, and I factored, and I factored. And I know those roots don't match, but you get it. Okay? Okay, whatever. And let's go to this one. Okay, how many times does it cross the x-axis? It crosses 1 time. That means it's a horizontal translation. Left 1. Okay. This one doesn't cross the x-axis at all, and this is a vertical translation. Up 1. Let me color code, of course. Remember, when it's vertical, it's with the y. When it's horizontal, it's with the x, but it's not a straight shooter. Okay. And let's go down over here. This crosses the x-axis 2 times. It's a vertical translation, down 1. Because of the negative 1, it's not with the x, it's a straight shooter. Okay. How many times can a polynomial of degree 3 intersect the x-axis? It can do 3 times. So if I did like this, 1, 2, 3. It can go 2 times, because it can bounce, right? 1, 2. It can cross 1 time. It can't cross 0 times because this one's going up and this one's going down, so it's eventually going to hit the x-axis. Can a third degree have no real roots? No. They all have to. We just talked about that. Okay? This one, let's see. Now consider the polynomial. How many real roots could they have? You could have, whoops, you can't see that. You could have 3 real roots. Verify that that's equal to that. So I could either factor this or I could box this. I think I'm going to box it. Now, if I was to factor it, let's say you go, you know what, I want to factor it. Well, that's fine. And when I see that there's 4 of them, I would do factor by grouping. But if you factored it by grouping, I'm just going to kind of show you that real quick. There would not be a match. And so you go, oh, that means it's not factorable. No, you're going to learn at the end of this chapter that there's another way to figure out what the answers are, what the roots are. Okay? But it looks like factor by grouping. It won't be. All right, so let's do x cubed These are all things you're good at. You can copy it or you can try it yourself to make sure you're solid. X cubed minus 3x squared plus 3x minus 2. X cubed minus 3x squared plus 3x minus 2. Can it be factored further? So what they're saying is, can I take this and can I keep factoring? And no, I can't find two numbers that multiply to get 1 and add to get -1. So it's no. Now they want you to find all the roots. So I'm going to rewrite what I have. Okay, zoom that out a little bit. So I'm setting it equal to 0 when they're asking for the roots. Let me just double quadruple, setting it equal to 0. Okay, that one's no problem. This one I can either solve by the quadratic formula or completing the square. In this case, I think I'd rather do the quadratic formula because my b is odd, and I don't, when I cut my box in half, like if I completed the square, that'd be 0.5x. When I go x minus 1 or minus 0.5, I just don't want to deal with decimals. I don't like them. I can do the quadratic formula. It's just a little annoying, but I feel like it takes less thinking for me than completing the square. Now, can you solve by completing the square? Yeah. Have fun with that. Okay. Okay, there's the 1, there's the 2. This would be the square root of 1 minus 4, which is the square root of -3. You can't take the square root of a negative, so that's imaginary, and you cannot take the square root of 3. So we have how many x-intercepts? So how many times does it cross the x-axis? Well, this is imaginary, so it doesn't cross that at all. It crosses 1 time, 1 real, 2 complex. Okay, this should kind of be almost kind of not a waste of your time, but if this section doesn't feel like, Ms. Rifkin, why are we doing this again? Then you need to go back, because this just needs to be tying it all together and make sure you're solid. Okay, for each following polynomial function below, determine all the roots. Okay, so if they want the roots, that's what they're saying, setting it equal to 0. I need to get a new pink pen. So I'm going to set, degree. The degree would be 3, because if I re-multiplied this out, I get x cubed plus x squared minus x. Or I could go, hey, there's 2 here, x's, and there's 1 there, and that makes 3. One of the real roots, if I set x equal to 0, it's 0. Now, if I set this equal to 0, we learned that that's imaginary. So this x is 1 plus or minus I rad 3 over 2. So this one has 1 real root and 2 imaginary. It's a cubic, and it's positive. So it crosses at 0, and then it doesn't cross anywhere else. So one option is it could go like this. Another option is, and we could graph it on decimals. I just don't want to. I don't feel like it. Wait. It could go like this. I'm not very good at this stuff, but that's okay. Maybe I'll make it look a little bit nicer. All right. But you get the game. I can always copy it off decimals. All right. But what I want you to see is here's the real root, and there's that x equals 0. Okay. The degree, I've got 2 here and 2 here. That means 4. How many real and how many complex? So if I'm doing the roots, I got to set these equal to 0. So I'm going to go x squared plus 1 equals 0. X squared equals -1. Square root, x equals plus or minus I. And then x squared minus 4 equals 0. This should be second nature. If you go, Ms. Rifkin, you're going way too fast. Okay, what I need you to do is go back and make sure you're solid on factoring. Make sure you're solid on solving. Make sure you understand the difference between a real root and a complex root. If I start saying things and you go, I don't know what she's talking about, go back, because that should give you a signal of what you need to focus on. And so when you get to this section, it's no problem. Okay, if it's the 4th power, it's called a quartic, and it's a positive quartic. Okay, so that means it crosses at +2 and -2. Now, if I'm doing a quartic, it's x to the 4th power. It starts up here, 1, 2, 3, 4. Now, I don't know about you, but before I graph it on here, I kind of want to see how it's going to look. Okay, so I could go like this, 1, 2, 3, 4. It could look like that. But I'm actually going to be a little mean because I'm going to require you now to find the y-intercept. So if you're going to find the y-intercept, you've got to plug in 0. So if you plug in 0 here, let me show my work. So I'd have 0 squared plus 1, 0 squared minus 4, which we know 0 times 0 is 0, so we really have 1 times negative 4, which is negative 4. So you're going to have to show me that work if that's a question that's on your quiz. So 1, 2, 3, 4. So now that might look a little better. That might not be exactly how it looks, but you get the game. 2 reals, 2 imaginary. Okay? Over here, I'm going to have to set these both equal to 0. This one, I can actually factor it. X plus 2, x minus 1, x equals negative 2, x equals 1. Oh, degree 2, 4, because there's 2 here and 2 here. If I set this equal to 0, that's the one we did up here. So that's x equals positive 1 plus or minus I rad 3 over 2. So I got 2 reals, 2 imaginaries. It's called a quartic. If I'm going to find the y-intercept, I need to plug in 0. So anything times 0 is 0. Anything times 0 is 0. That's negative 2, 0, 0. And then positive 2. Okay. So now I know it crosses at 0, 2. Negative 2, positive 1. Okay. And I know that there's 2 real. I know it's quartic. 1, 2, 3, 4. So 1. This one is not going to be as easy for me. Hold on one second. So to be honest, I was confused because I started going like this. And if I go through, I'm going to go past the y-intercept. So then I went, oh, okay, well, the only way that's going to work is if it's a bounce, but it can't bounce. So if you look, it's kind of hard to see it. But if you click, it's almost like it goes right, right underneath. So it's going through. Oops, it's like, I'm not doing a very good job of this. So it looks like it's before. Okay, but you get the game. All right, so let me just show you. There's nothing wrong with doing that to help you out. All right, let's go to the next page. And I think for the homework, I'm going to do, actually, I think I can crank it out. Let's see. So they want you to sketch a graph of each of these. So if you look at the next page, I have some examples. Okay, so they want a graph based on the given information. So they want 4 reals. 1, 2, 3, 4. So 1, 2, 3, 4. That's an example. 2 real, 2 imaginary. I'll make them here. 1, 2, 3, 4. 6 complex. Okay, so that means it cannot touch the x-axis at all. 1, 2, 3, 4, 5, 6. And some of you go, well, how do you know? Well, if it's to the 4th power, 1, 2, 3, 4. 4th power, 1, 2, 3, 4. 6th power, 1, 2, 3, 4, 5, 6. 1 real, 2 complex. So 1 real, 2 complex. Cubic. Cubic. To the 6th power, to the 4th power, to the 4th power. So now you know how to do this problem here. This is a review of what you did in the section before. This should be negative 2 rad 7 and negative 2 rad 7. So I guess it's just multiplicity 2 or it's a bounce. Okay. All right. And then this one, consider this. What are the zeros? So factor, sketch it. This one, solving each of them. Hint, hint, nudge, nudge. You might need to log both sides. This, all they want you to do is plug in negative 3. Then they want you to plug in I. Okay, so remember the rules for imaginary numbers. It seems like this would be something that would be on your quiz. And this is it. That was a shorter lesson.